Okay, if we look at the problem on the board, it says polynomial function with rational coefficients has the following zeros, find all additional zeros. So there's a couple things we need to do. We need to understand what find all additional zeros mean. So we need to have a couple things. One is, we talked about this before, but remember it's the conjugate root theorem. Okay, and basically what this says is that if I have an irrational or an imaginary root, I also have its conjugate. And conjugate, we're basically saying it's the opposite. Okay, so you also have its conjugate root as a 0. Okay, so in this particular problem, I just want to find additional zeros. I'm not writing a polynomial function. All I'm doing is writing the additional zeros. So the 1 here is not irrational and it's not imaginary. So therefore, that I can't do anything with. If I look at the 3 plus 2 root 2, that is irrational because the square root of 2 is irrational. Okay? So because that's irrational, that means it's going to have an opposite or a conjugate of it. And in order to find out and do conjugates, basically what happens is I take the numbers. They're the same, I'm not doing anything with them. All I'm doing is taking the sign in front of the irrational or imaginary part, and I'm just flipping it. Okay, so if this was negative, then this would be positive down here. Since it's positive up top, then it has to be a negative down below. The same thing here. This I makes this root imaginary. Okay, therefore, I can flip this one to be negative 3 minus 3i. So this problem turned from a 3 root polynomial to a 5 root polynomial because the conjugate root theorem states that I have to do I also have the conjugates as zeros. Looking at number 2. All right, again, we're going to use the conjugate root theorem if I need to. This square root of 10 is irrational. Okay, and 2i is going to be imaginary. So therefore, with both of these roots, I also have the conjugate roots that I have to include. Well, I have to write them as negative 1 minus root 10 and negative 2 minus 2i. So this is now a 4-term or a 4-root polynomial, x to the 4th power somewhere down the line when we do that. Okay, here's number 3. So those are your two answers, 3 minus root 5 and 2 minus 2i. Again, now this is a 5-root polynomial, or a polynomial with 5 zeros. Okay, we got one more like this that you guys can do yourself. All right, so this would be negative 3 minus 2 root 2 and negative 2 plus 2i. So those are your conjugates for number 4. Now, using that information, we are now going to write a polynomial function. So we're going to start off easy and then get it progressively harder. So here I have 2 zeros already given to me, and what I need to do is make sure that I don't have any additional zeros. So how do I know if I have additional zeros? Well, according to that conjugate root theorem, if I have an imaginary root, which I do, then I also have its opposite, or its conjugate. So negative I is also a root. Now, I'm going to use the parentheses, okay? Put them in the binomials. So these are the roots, but I'm going to go backwards and putting it into binomials. So how do I do that? Well, I am basically flipping it. So x plus 4. Now the reason I get a plus 4 is because technically it's x minus and then the negative 4. Well, two minuses right here and here make a big plus. So that's why I'm able to write a plus sign. Okay? That's the reason we flip. So then the next one here, which is x minus I, because that's the opposite of positive I. And then the next one would be x plus I, because that's the opposite of a minus I. It's same thing, x minus, and then that would be a positive I. And then x minus, and that would be a negative I. So this here would make that one, and this would make that one. That is why that's why I can just skip that step, because a minus of a negative of something is just the opposite. So that's why we're flipping them. Okay, then I'm going to erase this a little bit here. So now what I want to do is I actually want to multiply this all out. And how would I do that? Well, I'm going to take the two opposites, one's positive, one's negative. Okay, and we talked about a shortcut where instead of putting it into a box, you get the same answer if you do, that I can do it in my head right from there. So I am going to multiply the first terms, and that's your x squared. Oh, I can use the same colors here. So x squared. Then I'm going to multiply the last. So negative I and positive I. Well, that gives me negative I squared. So x squared is going to stay the same. The I squared, remember from, we talked about introducing imaginary numbers, right? I squared is always negative 1. So it's minus a negative 1. Well, what happens to it? Two negatives make a positive, x squared plus 1. But then, my x plus 4. Okay? So I have to multiply those two now. I want to find out what it's going to give me. So again, I can make my box. And when I do that, I get x to the third, 4x squared. I get 1x, or just x, and then 4. If I look at my diagonals, here, that diagonal, you see something. Well, you see that they cannot be combined because one's a squared and one's not a squared. So my answer would then be p of x, polynomial of x, right? Polynomial function is x to the third power plus 4x squared plus x, or 1x, plus 4. And that is your polynomial function of least degree that has those given 0. Okay, again, if you're having problems or I'm going too fast, again, pause the video to make sure you can keep up. Okay, that's what these are for. Let's go to number 6. Again, I have to make sure I don't have any additional zeros. So this square root of 10 is irrational. So therefore, I also have negative square root of 10. Okay? So now I can write it in my my binomials. So remember, this is x minus a negative 5, x minus the root 10, and x minus negative root 10. So this is x plus 5. This is x minus root 10. And this is x plus root 10. Again, we're skipping that step. Okay? We don't have to do this all the time. We can go right from here all the way down to that second step. And that's what hopefully we can do starting that way, so we don't have to go and write all that stuff down. To save some room, save some time. Okay, so I have negative root 10 also. Now, let's do the conjugates. Okay, x minus root 10 and x plus root 10. Let's multiply those together. Again, doing the same thing. I'm going to multiply the first two. I get x squared. I'm going to multiply the last two. Negative root 10, positive root 10. I get negative 10. Remember, anytime you multiply by the same roots, so root 10 times root 10 is equal to the number inside. Okay, so if it was root 25 times root 25, then I would get 25. Same applies all the time. Okay, so x squared minus 10. Then I have to multiply by the x plus 5 from the beginning. Again, you can do a box. X squared minus 10, x, 5. X to the third minus 10x. 5x squared, negative 50. So this would be p of x equals x to the third plus 5x squared minus 10x minus 50. And that is my final answer.